Now I am starting a new chapter, sequence and series. You know that A1, A2, comma, A3, comma, A4, dash, 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 comma, En. This is a sequence. It is a sequence. And here En is denoted to represent nth term of sequence. Here En is nth term of a sequence. If number of terms are finite, it is said to be finite sequence. And if number of terms are infinite, it is said to be infinite sequence. So if number of terms are finite, then it is said to be it is said to be finite sequence. And if number of terms are infinite, then it is said to be infinite sequence. Here A1, A2, A3, A4 up to An, these are real numbers. Now meaning of a series, next word is series. Say, I am putting an expression. If I put here A1 plus A2 plus A3 plus An plus and so on, it indicates sum of terms of this sequence. Sum of terms of this sequence. So this expression is said to be the series associated with given sequence. So this expression is said to be series associated with given sequence. Now it is nothing but sum of terms of given sequence. This series can also be finite series or infinite series, depends on sequence. If sequence has a finite number of terms, this is finite series. If sequence has infinite number of terms, this is infinite series. So here series can be finite or infinite depending on sequence. If sequence is finite, series is finite. If sequence is infinite, series is infinite. And here such expression, it can be denoted in compact form using symbol sigma. So A1, if I put here A1 plus A2 plus A3 plus up to An, then sum of first n terms of this sequence, that means we can say it is sum of series. This is said to be sum of series. So this is sigma a k equal to 1 to n. In short, this is denoted as sigma a k 1 to n. That means sigma is a one type of machine. What it does, it keeps k equal to 1. So a1, then it does plus, then it keeps k equal to 2. So a2, then it does plus, then it keeps k equal to 3. So a3, then it does plus. Continuing this procedure, machine keeps value of k till n. So last value of k is n. So an, so plus an, then full stop. So this is the meaning of this symbol. So it is sum of series. So this is said to be sum of series. Now questions to understand these symbols. So see, question is, write the first 5 terms of the sequence whose nth terms are given by these formulas. See, these are nth terms of a sequence. Now see, to find first 5 terms, here I am putting n equal to 1. So a1, putting n is 1. So 2 into 1 minus 6 by 3. So it is 2 minus 6 minus 4 by 3. It is first term. To find second term, we keep n equal to 2. Putting 2 here, 2 into 2 minus 6 upon 3. So 4 minus 6, that is minus 2 by 3. Putting 3, n equal to 3, 2 into 3 minus 6 by 3. So it is 0. Putting 4, n equal to 4, 2 into 4 minus 6 upon 3. So 8 minus 6, 2 by 3. Then 5, n equal to 5, 2 into 5, 10 minus 6 by 3, that is 4 by 3. So answer is first 5 terms are minus 4 by 3, comma, minus 2 by 3, comma, 0, comma, 2 by 3, comma, 4 by 3. So these are first 5 terms. Now in this question, if this is nth term, then putting n equal to 1. So minus 1 raised to 1 minus 1 is 0. 5 raised to 1 plus 1 is 2. So this is 25. Putting n equal to 2. Minus 1 raised to 2 minus 1 is 1. 5 square. Here 2 plus 1 is 3. So it is minus 125. Putting n equal to 3. 3 minus 1 raised to 3 minus 1 is 2. 5 raised to 3 plus 1 is 4. So this is minus 1 square is plus 1. 1 into 625. So 625. Then fourth term. So minus 1 raised to 4 minus 1 is 3 into 5 raised to 4 plus 1 is 5. So this is minus 1 cube is minus 1. 5 raised to 5, that is 625 into 5. So 300, 125. Fifth term is minus 1 raised to 5 minus 1 is 4 and 5 raised to 6. Minus 1 raised to 4 is plus 1. So it will be plus into 5 raised to 6. So multiply this number by 5. 3125 into 5. So it will be 3000 into 5, that is 15,000. 100 into 5, that is 500. 25 into 5, that is 125. So this is 526 so plus 15625. So these are 5 terms, first 5 terms of this sequence. So answer is first 5 terms are 25 comma minus 125 comma 625 comma minus 3125 comma and 15,625. So these are first 5 terms of this sequence whose nth term is given. So if formula for nth term is given, any term among that sequence can be found. Here this is an. So we need 20th term. So what we do? Put here n equal to 20. If you want 200th term, put n equal to 200. Whatever you need, put value of n. So putting here n 20, so it is 20 into 20 minus 2 upon 20 plus 3. So this is 20 into 19 upon 23. So 380 upon 23. So this is 20th term of this sequence whose nth term is given. Now next topic is arithmetic progression. In short, A dot P. Arithmetic progression or arithmetic sequence. See, here if I put sequence, any sequence, it is of this form: A plus D plus A plus 2D plus A plus 3D, like this. So any sequence of this form, observe here sequence, each number is increased by D, every number is increased by D. That means difference between two numbers is constant. So see, check here, second term minus first term, difference is D. Third term minus second term, difference is D. Each next number is increased by constant D. So here D is said to be common difference. And in this sequence, if we put here expression for nth term, then we can keep it by observation. Say, look here, first term is A, second term is A plus 1D. A plus D means 1 times D. Third term we are adding 2D. Fourth term we are adding 3D. Fifth term we will add 4D. So continuing this procedure, in nth term we are adding 1 less D, 1 less time D, that is n minus 1 times D. So this sequence is said to be an arithmetic sequence or arithmetic progression. Say here A is first term. A is said to be first term. D is said to be common difference. And formula for nth term. Formula for nth term of arithmetic progression is, this is the formula for nth term. It is an equal to a plus n minus 1 into d. This symbol, it can also be expressed as Tn, an or Tn is a plus n minus 1 into t. And if we take sum of first n terms of arithmetic progression, sum of first n terms of arithmetic progression, formula is sum of n terms is n by 2 into 2a plus n minus 1 into d. Sn is n by 2 into 2a plus n minus 1 into d, or another form is Sn equal to n by 2 into a plus last term, where L is last term, that means nth term, where L is nth term or last term. So next exercise is based on these two formulas. These are two main formulas on which next exercise is based on. So now we are doing questions on these two formulas. Find the sum of all natural numbers lying between 1000 and 1000. Say here, all natural numbers lying between 100 and 1000. So numbers between all natural numbers lying between 100 and 1000 are, see, word is between 100 and 1000, which are multiple of 5, multiple of 5 are, so if we keep list of numbers, then because word is between 100 and 1000, so don't include 100, don't include 1000, even though these are multiples of 5. We want multiples of 5 between 1000 and between 100 and 1000. So first number in this range is 105, next is 110, then next is 115. So say these are multiples of 5, or numbers we can say divisible by 5. And last number before 1000, it will be 995. So we are having last term too. So sum of these numbers, to find sum of these numbers, first of all we need, these are how many terms. So say here first term is A is 105, A is 105, last term an is 995. We want a number of terms. We are supposing that this is nth term. Consider this as nth term. This is first term. This is nth term. We don't know what is value of n. So first of all we are finding n. So first term A is 105, last term is 995. Difference, common difference is 110 minus 105. So that is 05. So putting these values in this formula, an is equal to a plus n minus 1 into d. An our last term we know 995 equal to a is 105 plus n that we want to find. Unknown about n. What is order of this term? This is first term, this is second term, this is third term. We don't know what is order of this term. So into d. D is 5. Here I am putting 5. So that is now, so 995 minus 105 equal to 5n minus 5. Now 995 minus 105, 5 minus 5, 0, 9 minus 0 is 9, 9 minus 1 is 8. So 890 equal to 5n minus 5. So 5n equal to 895. So n is equal to 895 upon 5, that is 5 into 1 5, 5 7s are 35, 5 9s are 45. So n is 179. So here this is 179th term. So 995 is 179th term. So here we want sum of first 179 terms of given sequence. We want a sum of first 179 terms. Now to find this sum, either we can use this formula or you can use this formula, because last term here we know last term is here 995. Because we are knowing last term, we can also find sum of n terms from this formula. We can also calculate from this formula. Any formula can be used. So let us use Sn equal to first formula n by 2, 2a plus n minus 1 into d. In this formula putting values, n is 179. Here 179 by 2 into 2a, a is 105 plus n is 179 minus 1, difference is 5. So that is 179 by 2. This will be 210 plus this will be 178. 178 into 5. 178 into 5, 40, here 4, 9, 3, 8, 890. So this product is 890. So here this will be equal to 179 by 2 into 890 plus 210. So that is 1100. So 179 into 550. So 179 into 550 multiply 55. 5 nines are 45, 4, 35, 9, 3, 8, 895. So 5, 14. So 98450. 98450. So this is answer. It is sum of all the terms between 100 and 1000 which are multiple of 5. So this value can also be calculated by second method. Second method is Sn equal to n by 2 into a plus l. That is, n is 179, a is 105, a is 105, last term is 995. This is last term. So 179 by 2 into this is 1100. So this is second method, 98450. How many terms of the arithmetic progression -6 -11 by 2 -5 dash 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 are needed to give the sum -25? So we suppose that sum of first n terms of sequence -6 -11 by 2 -5 dash 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 is -25. So here sum of first n terms is -25. First term of this sequence is -6. Common difference. So this is AP. Common difference, that is second term minus first term. So what is it? -11 by 2 plus 6. So 12 minus 11, 1 by 2. You can verify that is it a arithmetic progression. So see, -6 plus 1 by 2 is -11 by 2. -11 by 2 plus 1 by 2 is -5. So each term is increased by 1 by 2. Given progression is AP or not? To determine that, at least you should check first three numbers. See, -6 plus 1 by 2 is -11 by 2. Now -11 by 2 plus 1 by 2, it must be -5, and here it is. That's why common difference is constant. D 1 by 2 is constant. So this is D. Now using the formula, Sn is n by 2 2a plus n minus 1 into D. Now putting values in this formula, Sn is -25. Sum of first n terms already given, -25. N is, that we want to find, n by 2. 2 into a -6 plus n we want to find. D is 1 by 2. Now simplifying this is 2 we are taking on this side, so it will be -50 equal to n into, this will be -12 plus n minus 1 by 2. Now again I am taking here LCM. So minus 50 is n into minus 24 plus n minus 1 by 2. Again multiplying this 2 on this side. So minus 100 is n into n minus 25, that is n square minus 25n plus 100 is 0, and here we can factorize it, that is n minus 20 n minus 5 is 0. So that is n equal to 20 or n equal to 5. So sum of either first 20 terms or sum of first 5 terms is minus 25. So this is happening here because here there are two possible answers. Because if you add here, if you think about first 5 terms, so if you take here first 5 terms from this sequence, then its sum will be minus 25, and then if you take 20 terms, then also sum will be minus 25, because after a few steps positive terms will be started. So positive and negative few terms again that will be cancelled. So sum remains same in these two cases. So here answer is 20 or 5. So therefore either sum of 20 terms, sum of first 5 terms, or first 20 terms will be minus 25. Now in this question, in AP first term is 2. Here first term is 2. Sum of first 5 terms and sum of first 5 terms is equal to 1/4 of next 5 terms. Sum of first 5 terms is 1/4 times next 5 terms. Now how to express here next 5 terms? Sum of next 5 terms. Say if I take here a1 plus a2 plus a3 plus a4 plus a5, it is sum of 5 terms, and a1 plus a2 plus a3 plus a4 plus a5 plus a6 plus a7 plus a8 plus a9 plus a10, that is sum of first 10 terms. This symbol is for first n terms. So sum of first 5 terms, this is sum of first 10 terms. Now here word is sum of first 5 terms, that is S5, is equal to 1/4 times sum of next 5 terms. These are first 5 terms, these are next 5 terms. So we want to put this value here. Sum of next 5 terms, that means this value. Now how this can be defined? So this can be defined as S10 minus S5. So what is it? It is S10 means this series S10. So sum of 10 terms, first 10 terms minus, if you subtract sum of first 5 terms, then value of sum of first 5 terms will be deleted. So what is left? Sum of next 5 terms. So sum of next 5 terms, this can be expressed as S5 is equal to 1 by 4 into S10 minus S5. So always remember this method, how to put expression for sum of next 5 terms or next 6 terms, whatever you need. Now we say this is 1. Now Sn is n by 2 into 2a plus n minus 1 into d. This is formula for nth term. Now from this formula we calculate S5 and S10. These values we want to substitute in this equation 1. So n equal to 5. Putting here n equal to 5, S5 is 5 by 2 into 2a. 2 into a is 2 plus n is 5. So 5 minus 1 is 4 times d. That is, so this is 5 minus, I am putting in detail. So S5 is equal to 5 by 2 into 4 plus 4 times d. Taking 4 common, so 4 divided by 2 is 2, that is 10 plus 10d. So this is S5. Now we calculate S10, and for n equal to 10. Now put here 10. So 10 S10 equal to 10 by 2 into 2a. So 2 into 2 plus 10 minus 1 into d. And we have taken 10, a is 2. So that is, this is 5 into 4 plus 9d. So that is 20 plus 45d. This is S10. Now value of S5 and S10 we are putting in equation 1. So putting values in equation 1, S5 is 10 plus 10d is 1 by 4 times S10. S10 is 20 plus 45d minus S5 is 10 plus 10d. So that means 10 plus 10d is 1 by 4 times 20 minus 10 is 10, 45 minus 10 is 35 times d. So this is, multiply this by 4, 40 plus 40d is 10 plus 35d. So therefore 40 minus 35 is 5d is minus 30. So d is minus 6. D is minus 6, A is 2. If we have A and D, we can calculate any number of term. So we want 20th term. Now, putting these values in formula for AN. AN is A plus N minus 1 into D. That is, AN is A is 2 plus N minus 1 into D is minus 6. So AN is 2 plus 6, that is 8 minus 6N. This is formula for nth term. 2 plus 6 8 minus 6n. Now we want 20th term. So for n equal to 20, 20th term is 8 minus 6 into 20, 120. So it is minus 112. So this is required value. Now next question. If the sum of n terms of an arithmetic progression is Pn plus Qn square. Say here, sum of n terms is Pn plus Qn square, where P and Q are constants. Find a common difference. We want to find D. Now say in this formula, I am putting n equal to 1. So putting n equal to 1, S1, that is sum of first 1 terms, means first term itself. So S1 is P plus Q. So this is nothing but A1. It is A1. A1 is P plus Q. So it is equation 1. Now I put here n equal to 2. So putting n equal to 2, S2 is equal to, put here 2. 2 into P plus 2 square is 4. 4 into Q. Now sum of first 2 terms, that is A1 plus A2. A1 plus A2 equal to 2P plus 4Q. Now A1 is P plus Q. I am putting here P plus Q plus A2 is 2P plus 4Q. So that is A2 is 2P minus P, that is P, 4Q minus Q, that is 3Q. So this is second term. This value, it is from here, value from 1 is used. So first term is obtained, second term is obtained. So common difference is second term minus first term. So it is P plus 3Q minus first term is P plus Q. So common difference is 2Q. This is common difference. Now in this question, sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. Find ratio of their 18th terms. Here this is the question about two arithmetic progressions. Because these are two arithmetic progressions, they may have different first terms as well as difference common difference. So first of all, we suppose that let A1, A2, these are symbols for first terms, and D1, D2, these are symbols for common difference. B, first terms and common differences of two arithmetic progressions, two APs, arithmetic progressions. Now here this is the ratio of sum of n terms of both arithmetic progressions. So here sum of first n terms of first arithmetic progression. Now see, formula for sum of first n terms is a plus Sn is n by 2, 2a plus n minus 1 into d. This is formula for first sum of first n terms of AP. A is first term, D is difference. Now what I do? I replace A by A1, D by D1. So it will be sum of first n terms of first progression. So n by 2 into 2A1 plus n minus 1 into D1. This is sum of first n terms of first progression. Now I am taking ratio, its ratio with sum of first n terms of second progression. So for second progression we replace A by E2 and D by D2. So n by 2 into 2A plus n minus 1, here A2 D2. So this is sum of first n terms, same number of terms in both the sequences. Sum of n terms of first sequence, sum of n terms of second sequence. Its ratio is equal to 5n plus 4 upon 9n plus 6. So this will be cancelled. So this is 2A1 plus n minus 1 into D1 upon 2A2 plus n minus 1 into D2 equal to 5n plus 4 upon 9n plus 6. Now see, I am putting expression for ratio of nth terms of both the sequences because we want ratio of their 80th terms. Now formula for nth term is A plus n minus 1 into D. Formula for nth term A plus n minus 1 into D. Now what we do? If I replace A by A1, D by D1, then this will be nth term of first sequence. So ratio of nth terms of both APs, it is equal to A1 plus n minus 1 into D1. So this is nth term of a first progression upon, now replacing A by E2, D by D2. So this will be nth term of second progression. So A2 plus n minus 1 into D2. So this is ratio of nth terms of both the arithmetic progressions. Now what we want? We want ratio of 18th terms. So ratio of 18th terms equal to, we have to put here 18. So A1 plus 18 minus 1 into D1 upon A2 plus 18 minus 1 into D2. So it is A1 plus 17 D1 upon A2 plus 17 D2. So now this value we can find from this expression. So because this expression has pattern 2 times A1, here 2 times A2. So what we do, I multiply here by 2 numerator and denominator. So 2 times A1 plus 34 D1, 2 times A2 plus 34 D2. This is multiplied divided by 2. Now this value can be obtained from this equation. So what we do, I am putting n equal to 35. So for n equal to 35, so idea can be obtained from requirement. You have to think that what we need to find value of ratio of 18th terms. So therefore for n equal to 35, 2a1 plus 35 minus 1 34d1 upon 2 times e2 plus 34d2. It is equal to, putting here 35 upon 9 into 35 plus 6. So it is equal to, this is 175 plus 4 upon, this is 350 minus 35, 350 minus 35, 315, 315 plus 6, 315 plus 6. So it is 179 upon 321. So now this value we are taking there. So if we say this is 1, so it is equal to 179 upon 321. So it is from 1. Now let me check, is it divisible by any number? So if we divide this by 7, 7 into 2, 14. No, not divisible by 7. Not divisible by 70, not divisible by 11, 13, no. It is by 3, no. So this 179 is prime number. So we keep this as it is. This number is divisible by 3, but this is not divisible by 3. So required ratio, therefore required ratio is 179 is to 321. Now next question. If the sum of first p terms of an AP is equal to the sum of first q terms, then find the sum of first p plus q terms. Say formula, sum of first n terms is n by 2 into 2a plus n minus 1 into d. So we are applying this formula. Now we want sum of first p plus q terms. So say sum of first p plus q terms is required. So what I do, here I replace p plus q. So sp plus q equal to n by 2, n is p plus q, 2a plus n is p plus q minus 1 into d. So let me keep this as it is. I am putting this as it is. We want this value. We don't know what is first term, what is common difference. To find the sum of any number of terms or any term, we need two values. First term small a at common difference small d. But we are not having any value, neither a nor d. We want sum of p plus q terms, so substituting here n equal to p plus q, keep as it is. Now we are coming on given information. See here, what is given? Sum of first p terms, that is sp, is equal to sum of first q terms, that is sq. Now let me see what happens. Sp, so sp is p by 2 into 2a plus p minus 1 into d equal to sq is q by 2 into 2a plus q minus 1 into d. Simplifying this, here this 2 is cancelled. P into 2a plus p minus 1 into d plus q into 2a plus q minus 1 into d. So see, I am expanding this p into 2a, that is 2pa plus p into p minus 1d. So this is pd, p into pd is p square d. This is minus 1d, so p into minus d is minus pd equal to, here similarly q will be replaced by p will be replaced by q, so it is 2qa plus q square d minus qd. Now this implies, now we are arranging in such a way that we can get a relation between p and q. So say here 2pa, this is 2qa, so 2pa minus 2qa, put in bracket, plus p square d minus q square d minus pd plus qd minus pd, take this minus qd on this side, so plus qd, take plus minus common, so this is like this, or keep as it is. That we do in next step, minus pd plus qd equal to 0. Now say here 2a is common, p minus q, d is common, p square minus q square, minus d is common, p minus q is 0. Now p minus q is common, so p minus q common into bracket, what is left here, 2a plus d into p plus q, d into here p plus q is left, minus here d is left, equal to 0. Now say here p and q are not equal. Sum of first p terms of arithmetic progression is equal to sum of first q terms of that arithmetic progression. That means obviously p and q are not equal. So dividing this by p minus q, because this is not a 0, p minus q is not 0, 2a plus p plus q into d minus d is 0, because p is not equal to q, so p minus q is not 0. So from this equation we can say that 2a plus p plus q minus 1 into d is 0. And now you can see that this is visible there. We are going to use this value in this expression. Here it is 2a plus p plus q minus 1 d. So p plus q by 2 into 0. So it is from 1. So this is 0. So answer is sum of p plus q terms is 0. So in this question, sum of first p terms equal to sum of next q terms. Then in the remaining work we are shifting all the terms which are on right hand side, taking on left hand side and factorizing them. P minus q is a factor, so we get result 1. Now in this question, if sum of n terms of an AP, here sum of n terms is 3n square plus 5n and its mth term that is am is 164. So find value of m. Now mth term is 164. So see here, putting formula for mth term is m plus a minus 1 a plus m minus 1 into d. Formula for nth term is a plus n minus 1 into d. So formula for mth term is a plus m minus 1 into d is 164. So meaning of this statement is that a plus m minus 1 into d is 164. Now we want value of m, and it is possible if we know value of a and d, and value of a and d can be calculated from this result. So it can be calculated by finding S1 and S2. So putting here n equal to 1, S1 is 3 plus 5, that is 8. So S1 is A1, A1 is 8. Sum of first one terms, that is first term itself. So S1 is what? It is A1. Now S2. S2 is, putting here 2. So 3 into 2 square is 4 plus 5 into 2 is 10. So it is 22. S2 is 22. What is S2? It is sum of first two terms, A1 plus A2. A1 plus A2 is 22. Now A1 is 8. So 8 plus A2 is 22. So A2 is 22 minus 8, that is 14. So second term is 14, first term is A1. So therefore difference is A2 minus A1. Common difference is second term minus first term, 14 minus 8, that is 6. So here difference is 6 and first term is 8. So and a is 8, a is first term. Now taking this value here, that means a is 8, difference is, it is 6, equal to 164. Therefore 8 plus 6m minus 6 is 164. So therefore 6m plus 2 is 164. So 6m is 162. So m is equal to 6 into 2 12, 6 into 7 42. So m is 27. A man starts repaying a loan as first installment rupees 100. This is first installment. If he increases the installments by rupees 5, so next installment is 105, then next installment is 1110. Continuing this every month, what amount he will pay in the 30th installment? So we want 30th installment. This we want to find. What will be 30th installment? So say here E is 10, A is 100, first term is 100. Common difference is 105 minus 100, every month increasing 5, so difference is 5. Now formula for nth term is a plus n minus 1 into d. So 30th installment will be, a is 100, 30 minus 1, that is 29, into 5, d is 5. So that is 100 plus 135, sorry 145. So it is 205. 245. So 30th installment will be 245. This is answer. Now next topic, arithmetic mean. If A and B are given numbers, two numbers are given, and A, between A and B, if there exists a number capital A, if A and B are given numbers and these three numbers are in arithmetic progression, between A and B there exists a capital A such that these numbers are in AP, then this capital A is said to be arithmetic mean. It is said to be an arithmetic mean between A and B, and we can find this A. See, because these are in arithmetic progression, second term minus first term equal to third term minus second term. So from this relation, A can be calculated as A plus B by 2. So here A can be calculated by A plus B by 2. This is arithmetic mean. Now here between A and B there is calculation of only one arithmetic mean. We can calculate n arithmetic means. So between n arithmetic means, between A and B. How to find n arithmetic means between A and B? That means if between A and B, if I put here n numbers like this, and then next is B, last is B. If these numbers are in AP, then these are said to be an arithmetic means. A1, A2, A3 up to AN are said to be an arithmetic means between A and B. Now how to find these n arithmetic means? Say this is A, this is B. Arithmetic mean, that means at equal distance. So suppose this is A1, this is A2, this is A3, like this will be AN. This difference is D, this is A plus D, this is D, D plus D, 2D. So this will be A plus 2D, this will be A plus 3D. Here this will be A plus ND, A plus D, A plus 2D, A plus 3D, A plus ND. So this will be A plus N plus 1D. And now you can see that D can be obtained by B minus A upon n plus 1. So here D is B minus A upon n plus 1. It is clear in this last relation. A plus D, A plus 2D, A plus, this is A. So A plus D, A plus 2D, A plus 3D. These are in AP. A plus ND. Now one more D, A plus ND plus D. So A plus N plus 1D. Now from this last relation, B is A plus N plus 1D. So value of D is, shift A on this side. So B minus A upon N plus 1. So from calculating D, from D, after getting value of D, A1 is A plus D, A2 is A plus 2D, and so on. An is A plus ND. These n arithmetic means can be calculated. So this is the procedure to find n arithmetic means between given two numbers. Now next question. Insert 5 numbers between 8 and 26. So here A is 8, B is 26. We want to insert 5 numbers between A and B such that resulting sequence is an AP. So let the required numbers be 5 numbers. So A1, A2, A3, A4 and A5. So these are 5 required numbers we want to insert between A and B. So resulting is a arithmetic progression. So that means we want to insert 5 arithmetic means. So here this will be A plus D, A plus 2D, A plus 3D, just explained in theory part. So first of all we have to find common difference. Difference is B minus A upon n plus 1. B is 26. B 26 minus A is 8 upon. We want 5 arithmetic means. So n is 5. These are 5 arithmetic means. So n is 5. So this is 26 minus 8 is 14. Sorry, 18 upon 6. So D is 3. So difference is 3. This is calculated. Now A1 is A plus D. A2 is A plus 2D. A3 is A plus 3D. A4 is A plus 4D. A5 is A plus 5D. Putting values here, A is 8. So 8 plus D. What is D? 3. This will be 8 plus 2 into 3, 6. This will be 8 plus 3 into 3, 9. So 8 plus 3 into 4, 12. 8 plus 3 into 5, 15. So this is 11, 14, 17, 20, 23. So required numbers are 11, 14, 17, 20 and 23. Now in this question, between 1 and 31 m numbers have been inserted. Say here 1 and 31. Between 1 and 31 I am writing m numbers. Suppose m numbers are a1, a2, let me take m1, m2, m3, or okay, we are taking same symbols, a1, a2, a3 up to am, then next last is 31. So say between 1 and 31 m numbers, these are m numbers are inserted, so that this is resulting into arithmetic progression. Now given that ratio of 7th and m minus 1th number is 5:9, here ratio of a 7th number, say word is number, not terms. These are m numbers. Out of these m numbers, 7th number and m minus 1th number. So don't do mistake in this question, because term word is not given. If 7th term is given, then this is first term, second term, third term, fourth term. So 7th term will be a6. So don't take a6, not 7th term, 7th number among these m numbers. So 7th number is a7 upon m minus 1th number. So here is before m minus 1th number, it is equal to 5:9. Now 7th number, it is how much term? 7th number is 8th term. So this is 8th term, 8th term, because this is first term, second term, third term. So 7th number is 8th term, and m minus 1th number is mth term of AP. It is 5/9. Now 8th term is a plus 8 minus 1 into d, and mth term is a plus m minus 1 into d, 5/9. Now what is a? A is 1. This is a. A is 1. So putting here 1 plus 8 minus 1 into d upon 1 plus m minus 1 into d. It is equal to 5/9. We have taken value of a 1. We want value of m. So here this is equal to, we need value of m, so getting expression for m. So here multiplying this by 9, 9 into 1 is 9 plus, let me simplify this, 1 plus 7d upon 1 plus m minus 1d equal to 5/9. That is, now 9 plus 9 into 7, 63d equal to 5 plus 5 into m minus 1 into d. That is, we want value of m. So this is 9 plus 63d equal to 5 plus 5md minus 5d. That is, 9 minus 5 is 4 plus 63D plus 5D is 68D equal to 5MD. Therefore, M is 4 plus 68D upon 5D. So, from this result we can calculate value of M. So, to have M, now we want D. So, what is D? So, next step is to calculate D. And see, D can be calculated from this sequence. So, here D is equal to, we are using this formula B minus A upon, these M numbers are inserted here, these are M arithmetic means. So, difference is B minus A, let me say this number as B, this is B. So, difference is B minus A upon M plus 1. So, difference is B is 31, 31 minus 1 upon M plus 1. So, D is 30 upon M plus 1. So, we substitute this value in equation 1. So, putting in 1 here, M is equal to 4 plus 68 into 30 upon M plus 1 upon 5 into 30 upon M plus 1. D is 30 upon M plus 1, it is taken in equation 1. So, putting in equation 1, we are getting value of M. So, M is equal to M plus 1 LCM, so 4M plus 4M plus say here okay, we are going to get expression in terms of M. So, 4M plus 4 plus 68 into 30. So, 8 into 3, 4, 24, 2040 upon 150. M plus 1 LCM is cancelled. So, this is value of M. Therefore, 150M is equal to 4M plus 2044. So, therefore, 146M is 2044. So, M is 2044 upon 146. Now, say 2044 upon 146, it is equal to, so divisible by 2, 7 into 2, 14, 3 into 2, 73 into 2, 146, here 1022. Now, 73 is prime number, 73 into 1 is 73. Now, how much is left? 102 minus 73, so 29 is left. So, it is 292. Now, 73 into 4 is 280 plus, okay, 192. So, it is done. 73 into 4, 280 plus 12, 292. So, value is 14. It is 14. So, this was the application of n arithmetic means between given two numbers. If a raised to n plus b raised to n upon a raised to n minus 1 plus b raised to n minus 1 is the arithmetic mean between a and b, find value of n. Say here, this is arithmetic mean between a and b. So, this is equal to a plus b by 2. arithmetic mean between a and b, a plus b by 2, it is this given. Now simplifying this equation, 2 I am multiplying on this side, 2 times a raised to n, 2 times b raised to n equal to a plus b into a raised to n minus 1 plus b raised to n minus 1. Therefore, 2 times a raised to n plus 2 times b raised to n equal to a into a raised to n minus 1, multiplying this number with this number, it is a raised to n, plus a into b raised to n minus 1, plus now turn of b into this number, b into a raised to n minus 1, and b into this number is b raised to n. So therefore, now this is 2 times a raised to n, this is a raised to n. So 2 times a raised to n minus a raised to n. This is 2 times b raised to n minus b raised to n. So direct we are putting a raised to n plus b raised to n is a into b raised to n minus 1, b into a raised to n minus 1. Now rearranging numbers, a raised to n, this number I am taking on this side, so minus b into a raised to n minus 1. Then this number I am taking on this side, minus a into, see we are arranging in such a way that in the next step we can get common. Here we can see that a minus b is coming to be a factor. So same we are creating here, a minus b. That's why this is taken first, this is next in second group. So now a raised to n minus 1 common, a raised to n minus 1 common, so a is left minus b is left, minus here b raised to n minus 1 is common, so a is left minus b is left equal to 0. Therefore, a minus b common, a raised to n minus 1 minus b raised to n minus 1 is 0. That means a equal to b, or a raised to n minus 1 equal to b raised to n minus 1. But a equal to b is not possible. But a equal to b not possible. Because these are different distinct numbers. So this is possible. A raised to n minus 1 equal to b raised to n minus 1. So it is a by b raised to n minus 1 is 1. And if any x raised to something is 1, that means this should be 0. So n minus 1 must be 0. So therefore, n is equal to 1.